Hello friends, welcome back to my YouTube channel. So in this section, I am starting the new subject of first semester, that is called engineering graphics. It is also called as the engineering drawing. So before coming to this, we all have to know is why do you need drawing to become an engineering. So first we'll start with why. So imagine you want to build a house. You tell the architect make a 3 BHK or 2 BHK. Can you build without the paper? No. There is only one language that the architect, any architect or engineering or client all to understand. So that language is called as engineering graphics or engineering drawing. So our engineering graphics is nothing but the language of talking with drawings. So it is the method of converting our 3D ideas into the 2D. So it is the method of converting your 3D ideas into 2D drawings on paper so that anyone in the world can understand and build it. So let's start it. Engineering graphing is nothing but the art and science of representing the 3D object into the 3D objects into 2D on paper so that anyone can understand and manufacture it. So today we'll see some introduction part. So you may have drawn the so many diagrams. So engineering graphics here in this what we'll do is to converting of our 3D object. It may be anything. For example, here I have an eraser. This is our 3D. So to convert this into the 2D diagram, so if you draw as it is on the paper, so I will tell you later, I will explain you how to draw this drawing. Wait, for example, I will explain you. So engineering graphic means conversion of our 3D diagram into 2D representation. 3D we want to 2D. It is nothing but our engineering graphics on the paper with the help of pencil. So here this is if you take any object, you can convert any object 3D view into the 2D on the paper only. So see, I have taken a eraser here. So if you want to convert, this is in 3D, no? So if you convert this 3D diagram into the 2D, see here, this is our front view of the eraser. So the 3D view of this eraser will be, I will draw it here. The 3D view of this will be, this is our 3D view. So convert this into the 2D view. 2D view is nothing but our, see here, if you see this diagram, the front view of this will be, it will look, if you press this, so if you press this, what happens, it look like, see here, front view of this will be like this. Front view of this eraser will be like this, no? So for example, it has the length of 60 meter and width of 20 meter.
Front view of the eraser.
It has a length of 60 and width of 20. So we need to draw it as it is with the same length, with the same dimension we need to draw. And if you want to see it from the, this is our front view, no? Our front view of this eraser will be like this. So if you want to see from the top, it becomes like this. This is front and this is our top view. So it look like this. I will draw it here. As it is, this is the top view of this eraser.
We need to draw it with the same dimension and same angle. I am drawing as it is.
Top view will be like this. It has the height of 10. So this is our length 60 and this is our height, that is 10 meter. See here, so in eraser this is our length and this is from here to here will be width and this is our height. Height will be 10, I have assumed height as 10 and width as 20 and this length will be 60. I have taken length as 60. So this is our top view of this eraser. I have drawn as it is. So this is nothing but our graphics. So to make it understand, we need to draw the 3D view of any object. It may be anything into the 2D view. So 2D view is nothing but in 3D what happens, we usually see the 3D view means 3 dimension. We usually 3D view means 3 dimension. We usually see the 3 dimension. Here we will see the length and height and width also we'll see here. And 2D view means 2D means we only see here only two dimensions, that may be length or width or height or width. Only two dimension will be visible in 2D view. See here in front view, the front view of this eraser will be 60 and 20, 60 10 to 20 and 60. It is nothing but L into width. This is our front view, and the top view of this eraser will be, this is length, no, length into this is height. The top view of this will be length into height, and the front view of this will be length into width. This is nothing, this is called as the 2D view, and this is the 3D view. So this is how we need to go into draw in engineering graph with all the same angle and same dimension of the any object, converting 3D into the 2D diagram on the paper. This is called the engineering graphics. So I will explain you. So today now we'll see the introduction of the engineering graphics, what it included and what we'll learn in this engineering graphics. One by one we'll learn, and there are so many things engineering graphics, there are so many things it involved. We have to perform all of them. We'll see one by one later. So first is introduction. Here we'll learn about some basic principles of engineering graphics and their significance and types of lines. So what are the types of lines it involved, and lettering and dimension and scales and engineering curves and drawing of the how to draw the circles, it may be circle, and rectangular, how to draw it, and the drawing instrument to draw the any diagram, what are the instruments we need to use and what are the instruments we required. Step by step we learn. And our second is we learn about the orthographic projection of points and lines. So orthographic projections of points and lines, here we learn about the principle of orthographic projection and some applications on projection of lines and points, and we'll also learn about the lines inclined to both reference lines. Both reference lines, it may be HP or VP. So I will tell you what is HP and VP. So first we'll see the orthographic projection. So orthographic projection means what? So orthographic projection is nothing but drafting of the any object, drafting of any diagram, 3D object into the 2D. So converting our 3D into the 2D is nothing but our orthographic projection. So we'll see, I will tell with an example. So orthographic projection means, so I will explain you in a very easy way. So when you take a photo of your bag, so you get only one view. So when you take the photo of your bags or anything, whatever the photo of your, if you take the photo of your feet, you will only get one view, no. But in engineering the one view is not enough to make a machine part. So we need to see it from the top and front and side view. So that is called our orthographic projection. Orthographic projection is nothing but seeing of any diagram, it may be anything. So see here, for example, I have taken a square here, seeing this from the top side and from the front side and from the side view, and making the diagram of the top view and front view and side view is nothing but our orthographic projection, converting the 3D. Now the square is in our 3D view, no. So converting this 3D diagram into the 2D representation, that may be top view or front view or side view with the same length and same dimension and with the same angle is nothing but our orthographic projection. So see here, I will explain you. This is the square, so it has the same length. For example, I will explain you here only. This is the square. So I will write the 3D representation of this box. I will draw it here, same as it is, and same length and same angle I will draw it here. So I am drawing the 3D view of this square. So make it straight. So you draw it correctly. This is our 3D view. So 3D view of this box. So to make it, so if you see from the top, if I press like this, so it becomes flat, no. So if I press, what happens if I press, it will look like, so it will look like this, no. So it will look like this. The top view of this will be, So the top view of this will be this square like this. This will be like this. This is our length and this is our width. Here our length will be 40 and width will be 40. So top view will be, we will see length into width is nothing but our top view. So if you see this from the front view, so if you see, so now top, if you see this from the top, what we'll see only this length and the width. The length of this box will be, I have taken as 40, no, and the width of this will be 40. So top will see only this portion, no, we need to draw whatever we seeing on the top. So now if we see this from the front, so front means this is top, means this is our front. So this is top, so this is our front, the front view, top view, and the bottom of this will be this one. So front view will see from the, if we see from the front like this, we'll see triangle, no, now also from the front view also we'll see the square. So now front view, this is the length, we'll see from the front, this is the length and this will be our height. So this is our length and this side will be our height. So this is nothing but our length into height. Our front view is nothing but our length into height. So this is our 3D. So this is called the, this is nothing but orthographic projection. This is what called the orthographic projection. By seeing the 3D object into the, from the front view and the top view, and the 3D view is called as the orthographic projection with the same angle and same dimension and same width. So here, so in orthographic projection we'll learn about some principles of orthographic projection and application of projections of lines and points and lines inclined to both reference planes. And our now, so I hope you all understand the what is the orthographic projection and projection of planes and solids. Here we will learn about the projection of plane, surface, triangle, square, rectangular, pentagonal, hexagonal and circle. So now here also we will see the some projection of the triangle. So you all know the, you may all know the projection of triangle will be like this. We'll see the projection of this from the different angle, how it the 2D representation of this triangle, how it looks. It may looks like this or like this. We'll see by analyzing the, solving the problem on this, we'll see in detail. And the square, the projection of the square we'll see, and the rectangular. So this is our rectangular, we'll see projection of this. This is a pentagonal. Penta means 5. So penta means 5. 5 means it has the, pentagon means it has the 5 sides. 5 sides is nothing but, see here, 1 2 3 4, this is 5. This is our pentagon. And hexagon means, hexa means 6. Hexa means 6. So which has the 6 face is called as the hexagon. This is our hexagon. It has a 6 face, 1 2 3 4 5 6. So penta means 5, hexa means 6, and circle means you all know like this. Now we will see the projection of these all. And next we will also see the sections and development of surface. Sections of solids, sections of prism, pyramid, cylinder, cone, and cut by the plane perpendicular to one reference plane. And development of surfaces, lateral development of prism, cylinder, pyramid, cone. So we'll see it. And in this will isometric projection. So here we'll see the isometric drawing of the planes and simple solids. We'll solve on it. So here the isometric projection means, isometric is nothing but the 3D representation of the any object is called as the isometric viewer. So 3D representation of, see here, isometric is nothing but 3D representation. See here, if you want, it is the house. It is, imagine it is a house. So the 3D view of this will be how. So 3D view of this will be this. This is our 3D view of the house. Now we'll see the isometric projection of this also. We'll see. So if you want to see from the for house, what happens? We see the for the front view and the bottom of this house will be. So if you see the from the top view of this will be like this. You could see like this. Here one line is there, no? Here also it comes. This is the top view of this house. And if you see this from the front, so front, what you will see only this portion. This is our door will be there, and here like this. This is our front. So front view of this home will be like this. This is our 3D view. So here isometric projection we will see the 3D representation of the drawing. So here we will see the drawing from the all the dimension. We will see the length, what's the length and width and height of that object we will see here, and with the help of that we will draw the diagram. And also we will learn about the computer aided drafting. That is nothing but our CAD, AutoCAD. So we need to draw the diagram. So here what we have to do is in AutoCAD we need to draw the diagram of our any object. So see a diagram of this square as it is in our AutoCAD, we need to draw it. And here we'll learn the introduction of AutoCAD and some basic comments. What are the comments we need to use by drawing of this square in the as it is, this square in the AutoCAD. And what are the comments we need to draw it. It may be line or it may be circle, it may be rectangular, it may be triangle, anything we need to draw. We need to learn some comments of this. And 2D drafting of simple objects. So we need to here we will draw the 2D. 2D means here this is called the 2D view of this object. Here we will also learn the 2D view of any object, how to draw that. 2D view is nothing but whatever I have told you here. No, this is the 2D. This is the 2D drafting of any object in the AutoCAD. So this is our basics of the engineering graphics. I hope you all are understood. So in next video we will see the what are the instrument we need to use for the drawing purpose and what are the rules, and we'll see what are the rules. We'll see the in next section. So I hope you all are understood this video. So if you like the video, like it, share it and subscribe for the more videos. Thank you for watching.